Hi everyone. Today we are going to continue to learn about chemistry in our physical science unit. Last time we learned about mixtures and solutions. Today we are going to learn the opposite. How to separate the items, the components inside of a mixture or a solution. We're only going to work with 3 substances today. Salt. You guys know what salt is. NaCl, sodium chloride. We put it on our food. The next item is going to be diatomaceous earth. This is something that is probably the first time you're hearing this word. Diatomaceous earth is a sedimentary rock which has fossils inside of it. Now, diatomaceous earth is a rock, but it's ground up into fine little particles, very, very much like a powder. And the third substance we have is iron filings. Now, iron filings come from steel, come from metal, and they're shaved down to create a very, very small sand-like texture. Now, what we're going to do is we're going to make mixtures and solutions again, but then we have to separate them. Now, the salt is going to be mixed with water. The diatomaceous earth is going to be mixed with water, and the iron filings are going to be mixed with sand. Now here I have 100 milliliters of water in my first cup, 100 milliliters of water in my second cup, and the equivalent of 100 milliliters of white sand in my third cup. Now I have my salt, my diatomaceous earth, and my iron. I'm going to add 5 mLs, or the equivalent, 1 scoop, of each of these substances to the corresponding cup. So first let's do the salt. Then I will do the diatomaceous earth. And finally, I will do the iron. Now notice my iron is grayish color and my sand is white today. I could have done any color sand. I chose white just to make it a little bit more obvious that we are using 2 different substances. Now I'm just going to mix using my popsicle stick. And let's see if you can remember how to identify a mixture and how to identify a solution. Okay, let's look at my first. This is my salt water. And what do we notice? It has completely dissolved into a clear liquid. Don't see any more salt, making this a solution, but we already knew that. My next one is the diatomaceous earth. And this substance does not look like it's dissolving. It is white and it is not clear, making this a mixture. And finally, I wanted you to see the color contrast between the gray and the white. Pretty obvious. This is a mixture. We know that because it's not clear, it's not a liquid, and the sand is not evenly distributed. And the iron is not evenly distributed in the sand. You'll see areas where there's a higher concentration of iron and areas where there is a lower concentration. The white areas don't have as much iron. Now the question is, how am I going to separate my salt from the water? How am I going to separate my diatomaceous earth from the water? And finally, how am I going to separate the iron from the sand? Take a minute, record in your sheet different ideas that you have that you could separate these items. How do you separate the solute from the solvent? Any ideas? Well, one way that we can separate a solute from a solvent could be filtration. Here I have a coffee filter and just a stand. And what I could do is pour each of my substances through, and hopefully the filter paper could catch the substance that I'm trying to separate, allowing the water to pass through. Now for starters, let's see, would this work? Could I pour my iron and sand mixture through here? I could try it, but just get stuck. Nothing would go through. There's no liquid here, so that's not gonna work. The diatomaceous earth, is this something that would work? Possibly. Still not dissolved. What about my salt water? Could I pour my salt water through here and catch the salt onto my filter? Let's try it and see. So I have my filter all set up. I have a cup to catch the contents. And the first thing I'm going to do is pour my salt water onto the filter. Looks like it's filtering pretty fast. And the water's coming out clear. Let's look at the top of the filter paper. Here is my filter paper. And let's take a really close look. There's nothing here. Well, no surprise, because the salt has dissolved in the water. So if it's completely dissolved, we're not going to be able to use a filter paper to catch the salt. So the salt water that I had is still here. Can you think of another way that we can separate the salt from the water? Go back and think about properties we know about water. What are some things that water does? What does water do on a hot day? Water likes to evaporate. What if we were to take this cup and evaporate out the water? Would we be able to see the salt left over? Let's try it. I have my salt water here, and what I'm going to do is I could place this cup in a sunny spot and wait for it to evaporate, but it would take a long time for this to evaporate. So I'm going to pour some of this on a flatter dish, increasing the surface area and decreasing the evaporation time. So as I pour my liquid onto my evaporation plate, I'm just going to do 2 just for good measure. And I'm going to place these 2 in a sunny spot and just wait. Next, I have my diatomaceous earth. Let's mix again and see. Absolutely not dissolving. I have my filter paper set up on my filter stand with a cup to catch the contents. I'm going to do one last mix, and then I'm going to pour the contents onto my filter paper. And let's watch and see what kind of water comes out. Is it clear or is it cloudy like before? Not as cloudy. Something is happening. Let's take a closer look. Our water is pretty clear. Well, one more place left to check. Let's check our filter paper. As I check my filter paper, well, what do you know? Look at that. What have I just done? Look at all that white powder. I got my diatomaceous earth back. I was able to separate the diatomaceous earth from the water using filtration. Well, that one was a lot simpler, right? I just had to use some coffee filters, pour my mixture in, and my solute stayed up the top. The diatomaceous earth I captured with my filter paper. Can leave this to dry, and we'll check it and see if we can get the water to all evaporate. Now we have the last one. We have the iron filings and my sand. How can I separate the two? With the filter paper, wouldn't work. Could I evaporate? No, there's no water here. Could I use some kind of another type of filter? Not really, because they're the same size. The color is different. Could I separate by color? Wouldn't be very efficient. It's a lot of sand in here. How can I do it? Think about the properties of iron. What do we know? Iron is a metal. It's steel. Steel is magnetic. Is sand magnetic? No. What if I used a magnet to separate the iron from the sand? Let's try it. For this part, I just transferred my mixture into a bigger container, and it's all spread out. What I have here is my magnet. See what happens when I bring my magnet close to my container. Wow! Is plastic magnetic? No, the sand is not magnetic. Something in there is magnetic. It's the iron. Let's take a look and see what happens when we bring our magnet close. Wow, look at that separation. As I move the magnet, the iron comes all to one side. Look at that. can take my magnet all throughout and try to move all the iron all to the same side. And then I can just transfer this out using my magnet carefully, and then going through again with my magnet and doing it one more time. I had 3 very different mixtures, and I was able to separate them using 3 different techniques. The salt water we separated using evaporation. Diatomaceous earth and water we separated using filtration. And the iron filings and sand we separated using a magnet. Now, we're not quite done yet. What I have here is a box of total cereal. Now, as I read the nutrition facts on the side, total cereal claims that it has vitamin A, vitamin C, calcium, iron. And it says it has 100% of the daily recommended allowance of iron inside of my cereal. Total cereal. Does it have iron in it? Is this the kind of iron that's in this cereal? Is that possible? Huh. Do you think there's iron in here? And if there's iron in here, how would you separate the iron from my total cereal? Take a minute and write down the ways that you could separate iron from total cereal. If total cereal has iron in it, then the cereal should be magnetic, right? Here's my magnet, and let's see. Well, it's not picking it up. Let's try it. No, that didn't work. Well, I went ahead and I crushed up the cereal because I thought maybe the cereal is too big. And let's try this again. I'm gonna bring my magnet really close. And what do you notice? The cereal crumbs have stuck to my magnet. But I'm not convinced yet. Maybe they're sticking because there's static electricity. A lot of different reasons it could happen. And I haven't separated my total cereal. And I haven't separated my iron from my total cereal yet. To take this even further, what I have is a plate that has water in it. And I'm going to place 4 flakes all throughout this water. And you'll see that the flakes are moving randomly. Now, if these flakes are magnetic, I have reduced friction by putting them in water, and let's see if we're able to move them using my magnet. Look at that. I'm not touching them. I'm just moving this. Going to attempt to take all of them to the middle. Again, I am proving that they are magnetic, but I have not separated out the iron. Now, any ideas on how to separate the iron from the cereal? Few hints. We saw that when we turned the cereal into crumbs, the magnet was able to pick it up. And when we kind of were floating it on water, we were able to move it around with the magnet. What if we dissolve it in water and then see if we can separate it? What I'm going to do is take a plastic bag and I'm going to take 1 cup of cereal. And to this cup, I'm going to add 2 cups of water. Seal the bag really well. And then I'm going to let this bag sit for 30 minutes to an hour, and then I'm going to test it again. Here is my bag that has been sitting. You can see turned into mush. Here I have my neodymium magnet, very, very strong magnet. Going to place the magnet on the palm of my hand. Place the bag right on top. And I'm going to move it around. Try to increase the surface area that my magnet is able to reach. Give it just a few more seconds and then flip it over. I have my magnet and gently I'm going to lift. And would you look at that? What do I have here? I have iron. See the black stuff? There should be about 19 milligrams of iron in here. It's hard to take it out of the bag right now and measure, but I was able to separate out the iron from my cereal. Let's try it again. Let's mix it up. Get rid of it. All gone. Put the magnet on my pan. Put the bag. And move it around. Gently place. Flip. And here we have it again. I was able to separate out the iron from my cereal. You can see how the magnet is pulling onto the bag and the iron is separated right on top. Now I did it using total cereal. If you want to try this, the steps are very, very simple. However, the materials that you may need are a little bit difficult and a little bit dangerous. What I have here is a neodymium magnet. These are very, very, very strong magnets. Your typical magnet that you may have at home isn't going to be able to separate the iron from the cereal very well. It might be a little bit. If you do happen to get a neodymium magnet, please be very careful. Please store it in a safe place. And whatever you do, do not bring it into contact with another magnet, especially a neodymium magnet. They are very strong, they are attracted to each other, and they are very hard to separate and can cause a lot of accidents. Another note, don't drop them either. When they break, they can be harmful. Make sure after you've used your magnet, you store it in a safe place so that it does not come into contact with another magnet or another neodymium magnet. Today we learn more about mixtures and solutions, and we learn how to separate the solutes from the solvent, or if we have a mixture, how to separate the different components. Think about other mixtures and solutions and how you would go about separating them. Make sure to complete the entire sheet attached in the descriptions part of this video. Good luck.